Hello all, very good evening. Thanks for joining the session. This is demo 2 on Docker and Kubernetes. Let me share my screen and then continue with the today's concept. So yesterday, again, let me explain about the course details and then structure and all. Probably you already have but let me explain one more time just for 1 or 2 minutes. So the course is the Docker and Kubernetes, and the duration is 35 to 45 days. Fee is 3000 INR, and a soft copy of the material you will get through the Google Classroom, and then the recordings you will get with the 60 days or 90 days validity. No prerequisites or no prerequisite is required to learn this. This is a separate concept actually. And even we have drafted what you're gonna do, what is the agenda actually. So the agenda is what we already have this CI pipeline, continuous integration pipeline. Now, in order to deploy the applications in the Kubernetes cluster, so you guys who are attending this session, you guys will be able to write the Docker files and then create the Docker images, create the Docker containers, and then able to write the Kubernetes manifest files, meaning the Kubernetes files, and then you will be able to deploy them in the Kubernetes cluster. So that is what the agenda and then target of these sessions. Let me do one thing. Let me again go and then open the content. Probably you know the content, but just in case, let me open the course content. Yesterday we even have discussed it, but let me quickly open it, the Docker content and then the Kubernetes content. Okay, so and also we have discussed yesterday about the plan, how we will execute the plan of the Docker. So first we thought to see the problem without the containerization technology, and then understanding the solution with the Docker, then what is Docker. So like that, yesterday I explained the plan actually, how we execute and all. And also yesterday I have glanced through the course content. That's the Kubernetes course content, isn't it? So we were seeing yesterday what is this Kubernetes, how much Kubernetes course content will be covered and all. I explained, isn't it? So today what we will do is, as part of our first point in the Docker learning roadmap, so we will see what's the problem if there will be no containerization technology and why we are going for the Docker. So I am starting the Docker session now. It will be continuing even after completing the demos as well. Once you register, from there I will continue, meaning this is the meaning I'm starting the session, Docker sessions today onwards, right? Yesterday I was explained the course content, roadmap and all. Now I'm starting the Docker course content, right? So the first topic in the Docker course content is, what's the problem if there will be no containerization technology, why we have to go for the Docker. So this is what, let us try to understand very clearly. Fine. So let me open the document. So first let us discuss the problem statement. So as per the Docker official website, the definition for the Docker is given as, Docker is a software packaging tool to packages the softwares as a containers. So this is where you will get the doubt, why we need to package the software as a container. What is the need of it? Usually when you will package your luggage, when you have an intention of transporting from one place to another place, isn't it? For example, you are going to some pilgrimages. What you will do, you will package the clothes and the necessary items in different bags, and then start your journey with those different bags, isn't it? So when you go to vegetables market, what you will do, you will package each and every vegetable in a separate covers, right? And then put all these into a big basket, and then you will be ship the vegetables from there to your home. isn't it? So when your thought is to ship from one place to another place, then you will package the things. Similarly, when also we want to ship the software from one place to another place, meaning one environment to another environment, we will use the packaging actually. So we will package the software, and that package we will shift from one place to another place. So let us understand this word in little bigger picture. What is the need of this packages? So in order to understand this, Docker is a software packaging tool to package the software as a container. To understand package the software as a container, to understand this word, let us go now and understand usually how the environments will be. What is environment? Tomorrow, if you got a job, assume you are selected as one developer, or maybe you might select as the DevOps engineer, or you might select as some software engineer, whatever the role it is. But usually you will work in a team, isn't it? So the team contains definitely the group of people, correct? The team contains definitely the group of people. That means there were the developers, there were the testers, there were the DevOps engineers, isn't it? There were the managers, architects, leads. So all these people work together to build one application. What is application? Application meaning a set of features where you will access them over the website is called the application, isn't it? It's a program. Application is a program, set of programs where you will access them over the internet. That is called as an application, isn't it? So let me just discard this. I would like to draw something to make it understand. Just let me discard it. Let me go to new diagram. Fine. So what I am saying is, in the real-time environment, we will have a different peoples, right? So that means we have the developers, we have the testers, right? So different teams we have. Assume this is the developer team, and this is the testers team, right? And assume this is the DevOps team. Like that, we will have a different team. So all these members will work together on an application, right? So application meaning a program, or for example, your Amazon.com or Flipkart.com, whatever you are accessing over a web, right? So that is an application which contains certain features in it, right? Where you will use them. So on this application, these people will work. So if we can take the case of these developers, what the developers will do is basically, so assume these guys are the developers. So in the case of developers, what will happen is these developers will write the source code. What is code? What is source code meaning? So the instructions, set of instructions they will write. It is like, just English language only, alphabetics only, or numbers only, but understandable format, understand to some technology. By using the technology understandable format, they will write some coding, some instructions they will write. So these developers will write the coding, isn't it? So these developers will write the coding. So for example, most of us know what is coding is, but just in case, if you would like to see how the application, what the coding is, see this. So here written something, this is called some code. For example, so here this is written. Let's say this department controller. So let me open, right? So this code has been written with respect to the Java syntax, Java programming language syntax. Like that, we have so many programming languages available, right? So according to the so many programming languages, using the programming language specific script format, the developers will write these instructions. These are simple instructions only, nothing is there. But however, what I mean to say is, these developers will write the code, right? So developers write the code. How they will write is, for example, this one person. Okay, so let me take this one person. So this guy, okay, so these are all working on one application called retail e-commerce, assume. So all are working on an application called retail e-commerce, assume. So now we are discussing about the problem statement. So in real time, we have the various environments like dev, QA, UAT, and production. Different environments we will have. So usually developers will write the source code and all the developer source code will be merged into a integrated environment. So assume these guys are working on one use case or one application. So what is the application is? Application is retail e-commerce. Retail e-commerce is the application. So retail e-commerce, what should be happened is, so these are all the use cases. Assume these are all the flow, at least should have to be happen. So user should be registered. So user or user registration, just to write user registration, and then user login, and then users dashboard, and then users orders, right? What are the orders they have placed? Orders, and the products what they have purchased, right? So assume these are all the requirements that the team need to be work on. Then assume the case one person, one developer started taking this point one, that is user registration. So this person, the developer one, what he is doing is he is started writing the code in his machine. So this is what his machine. In his machine, he started writing the code, right? So before writing the code, I would like to explain you one more thing also. When the project will be started, project architects will do what? They will first create a Git repository. I mean to say it may be Git or Bitbucket or whatever it is, but they will create one repository. In repository, what they will do is they will keep some code meaning some file, some application related files, they will keep it. For example, this is one application. So application related source code. Carefully listen. So some source code. Let me take simple files. This is the source code. Assume this is the source code files. So what these architects will do, they will create in this is the some GitLab or maybe GitHub you consider. So in GitHub or GitLab, what they will do is they will create a branch actually. They will create a branch. So like this, they will create one branch. So assume this is the main branch they were created. So in main branch, what they will do, in main branch, they will keep these files. Meaning project structure, they will create and then keep in this repository. So how the project structure, simple project structure they will create. For example, let me go here. This is what my repository. Okay, so the simple structure I was created, a simple structure. So simple structure, yes, this is the simple structure I was created. The project name I was given as Medilab Preclinic Applications and source code, build file, like that, a simple structure I was given. So this is a simple structure. So it's a simple structure I was given. For example, if I can go to GitLab. So let me go to my GitLab just in case. Yeah, I was already logged in, or just let me log in. If not, what I would like to showcase you is how the project will start now. So when the requirement analysis and then the designing phase is completed by the architects. Usually architects will do what? They will create a simple project. So they will create a simple project. For example, I want to create one repository. Okay. So here I want to create one project, simple project. If I want to create, I can create. So just I will showcase you how we can create a simple project. So let me go to here. Let me go to my projects. Let me create a project. So assume I'm an architect. Once after I have done my requirement analysis and all, with the requirement analysis, I came to know how many modules are there in the application, how many features are there in the application. With that, what I will do is I will create a project. For example, it is the Spring Boot project. Assume it is the Spring Boot project, Java project you consider. Okay, assume it is a Spring project. Now what I will do is I will create the application. Let's say Medilab free clinic, Medilab evening free clinic. So this is the application. Now I'm creating the application with the private access just to see my team members only, just to have the access to my team members. Now if you can see, a basic source code structure already came, isn't it? Now basic source code structure came. This basic source code structure, I was by default created in the master branch. I was by default created in the master branch. Now master branch contains what? The basic source code structure. So this is the basic source code structure which is there in the master branch. So architects will create such a basic source code structure, not basic actually. Application architects will do what? They will architect the applications, right? Meaning they know better how the application should be. What are the classes, interfaces, what is its structure and all, they know better, isn't it? So that is the reason. So they will create this project architecture and then keep inside the one repository. So assume this is the repository, main branch we were kept. So these files were kept in the main branch. Now every developer should have to, what they have to do is, so this person is the developer one. So this person is the developer one. So what this developer one will do is, this developer one will do what? Actually, in his machine, this developer one, what he will do is, from his machine, he will connect to first this GitHub repository. Okay. And after connecting, what this guy will do, he will create one branch. So he will create one branch. For example, this guy is working on the registration functionality. So assume this guy is working on the registration functionality. Then what this person will do? Is this person will create a branch in the Git repository. Assume that branch name is the registration. So the branch he will create like this. For example, he will create the branch feature/user registration. So user registration. So with this name, he will create one branch. So whenever you will create a branch, always the branches will be created from the existing main branches. So main branch already have the source code, meaning the project architecture. So what this person will do, this person will pull the source code into this user registration branch, and he will, that user registration branch, he will pull the source code into his local, right? So what he will do, he will pull the source code into his local and start developing the registration functionality. So this person will start developing the registration functionality. Similarly, there is another developer who is working. On the login functionality. So who is working on the login functionality? Assume this guy is working on the login functionality. Then what this person will do, this person also will create one more branch. This person also will create one more branch from the main branch, isn't it? So from the main branch, this person also will create one branch from the main branch. And this branch is nothing but feature slash registration. So assume he given the name as the feature slash user login. Feature slash user login. So this is what the branch name he given to it, right? And then he pulled the source code into his mission. So just let me delete this. So he pulled the source code into his mission from that branch. Okay, so this is the branch. Okay, now what will happen? There will be one more developer like this. There might be one more developer like this who is working on the dashboard. Assume this is one more developer who is working on the dashboard, right? Who is working on the feature called dashboard. Now what this person will do, this person also will take the source code, meaning this person also will create one more branch called feature slash dashboard, right? And then that branch always will be created from the main branch or the master branch. So feature, what it is, dashboard. So he will create this branch from this main branch. Yes. So this is from the branch he created another branch. From the main branch he created another branch. So this is main branch or master branch. Main or master branch. So what this main or master branch contains? It contains the source code, the primitive or the architecture, application architecture base code will be there inside this. Application architecture base code will be inside this main branch. Makes sense, right? Fine. So this is the base code. Fine. Now what will happen? Now what will happen is this guy completed the registration coding, right? And then this guy pushed the source code to his branch. He tested it in his local, everything is working fine. And this person also completed the coding of the login. He tested it and then everything is working fine. Then he pushed the source code to his branch called feature slash user login. Similarly, this person also completed his coding. And then once after he completed his coding, he pushed the code back to his source code repository. Okay, now individually dashboard is working, login working, registration working, individually working. But in order to test the complete flow, like user register first, then login, then see the dashboard. In order to complete this complete flow, these three branches source code need to be merged into another branch called release branch, isn't it? Then what we will do, these three branches, the integration branch, user login branch, and these three branches. So these three branches will be created into, meaning merged into one more branch called release branch. So this is what the release branch. Assume this is the dev release branch. So let us say dev environment, dev release 01 branch. Okay, so this is the dev release 01 branch. So in this dev release branch, what need to do? All the source code what they have pushed here, right? So that all the source code we need to merge from here. So from here we need to merge into it. So just let me take it like this. Right. So then this source code also we need to merge with this one. right? So we need to merge with this one. Let me take it like this, right? And what we can do, this branch also we need to merge. I think you are following me, isn't it? So this branch source code also we need to merge to here. So this I'll take it something like this. Perfect. Now the registration branch, user login branch, dashboard branch. These three branches source code will be merged into the dev release 1 branch. Okay, perfect. So far, I think you are clear. Now the code is there in the dev release 1 branch. All the integrated code is in the dev release 1 branch. Now what you will do, you will prepare the environments. So you will prepare the environments. So for preparing the environments, you might will take the virtual machines. So you might will take the virtual machines. So this is one virtual machine, or else let me take something like this. So this is one virtual machine. Okay, one EC2 machine you will take, probably one machine you will take. So this is called the dev environment, meaning dev machine, dev environment machine. So what we will do in this dev environment machine, carefully observe. Number one, carefully observe please. Number one, assume this application is the Java application. For a while you assume this application is the Java application. So number one, what we have to do, first we need to pull the entire integrated code into this dev machine. Sir, why we need to pull? Because developers were written there independently, they were written and then tested. But to test all the flow integratedly, they need one integrated environment, isn't it? So to test all the flows, what we want an integrated environment. That is what we are now building. That is called as the dev environment. So this is the Java application, assume for a while. So Java application requires what? We need to install the Java first in the dev machine. Now carefully observe, please pay the attention, because slowly we will go into the problem statement. So what we want, so that is a Java application. So we want to install the Java here. Okay, assume we installed Java. Okay, so we have to install the Java. Assume we installed Java. Right, so Java is what we installed. Okay, now the source code is using the build tool as Maven. So what we have to do, we have to install the Maven. Okay, so I was installed the Maven also here. Okay, then the source code is also using the UI source code. This branch also have the UI source code, UI branch and then backend branch. So UI source code required to be run using the Node.js. So assume I was also installed the Node.js. And then the backend application running, or to run the backend application or Java application to run, we need one server. So assume for that we have installed the Apache Tomcat server. So this is what we installed. Carefully observe. This is what we installed. Okay, this is what we installed. Then what we need to install? Our application is a connecting to database. So that database is MySQL. So we also need to install the MySQL. Okay, I installed MySQL as well. And our application is the React.js application. So React.js code I need to pull from the repository. So I was pulled the source code, the React.js source code. And also I was pulled the source code of our Spring application. So this is the Java application. So Spring Java application source code also I was pulled. Now everything we got. Then what we will do, using Maven, we will build the backend source code and then deploy in the Tomcat. Using Node.js, we will build the React application and deploy it in the Node.js server. And using the MySQL database, our application will connect to this MySQL database. Then what will happen? developers will access this machine, developer group. This is what we thought as a developer group, right? So this developer group will access this machine and they will access the application running inside the machine. So this developer groups do what? They will access this machine, meaning the application running in this machine they will access, and then they will test the application, right? So the application will be now running inside there, and that application they will test. So this is the application that they will test. Perfect. So this is the application. So this application they will access, which is running in this machine. So here the application is running in this machine. So that application they will access. Okay. So this is running in this machine. Perfect. So we were done one development environment. This is good. This is good. We were done one development environment, and in the development environment, what happened? The source code every time checking. So we are getting here, building it, deploying it, and then doing all these things. Okay, everything is working fine. All these three features are tested in the dev machine. Then what next? So we need to give this machine to testers, right? But before giving this machine to testers, what we will do usually we will create one more machine for the testers. We will create one more machine for the testers. So this is for the testers. Then what the testers will do, that means QA machine. So while setting up the QA machine, what we need to do? Again, we need to pull the source code from here to here. That is for sure. So again, we need to pull the source code from here to this QA machine. Again, we need to pull the source code. And to run the source code, we require the Java. So we need to install here. To build the source code, we require the Maven. We need to install Maven here. And our application, React application, to run it, we need to install the Node.js. And to run the Tomcat, meaning to run the Java application, Spring application, we need to install the Tomcat. And our application is connecting to backend database. So database is also we need to install here. Then the QA people, then the application will be started, and that application will be accessed by the QA people, and the QA people will test it, right? So QA people will test it, testers or tester or user. So QA team, so whoever are the QA team, so that QA team will test this application. So yes, so here is the okay. So I'm assuming that this is the testers team, and testers will test the application. Fine. So once the testing is also fine, testing went good. Then what next? Then what next is testing also went good. Then what next? We have to create one UAT environment. To do that, what we'll do? Let us take one more machine called UAT environment, user acceptance test environment machine. So again, we will pull the source code from this branch, meaning dev release branch, right? So similarly, here QA release branch also will be created. So this is the QA release branch. And similarly, UAT release branch also they will create. And whatever the QA release branch certified, right? That only automatically, or that only will be pulled into this UAT machine. QA release branch code only will be moved to the UAT machine. But what I'm telling is, again, you need to pull the source code into this machine. To run that source code, to build that source code, you need the JVM. So Java installation, Maven installation. Again, all these installations we need to do. What did you observe from this pattern? So what did you observe from this pattern? What did you observe is, whenever we will go to the new environment, we have to create all the softwares in that machine repeatedly. Like how many times we will spin up the new environments, those many times we have to create all these installations and all we need to do in the machines. That is the point number one you might observe. Now point number two is what you know, the source code, dev source code is different. And QA, again, we are taking the source code, especially separate for the QA. And that QA source code only, again, we are taking into the machine. Meaning every environment is pulling the source code and building the source code and deploying the source code. Assume there will be a code changes frequently occurs, which will be tested by the developers. The code frequent changes, once the developers done testing, developers done the unit testing and then integration testing, then it will be given to the testers to do the QA testing. So that QA testing will be performed again on the source code. Again, they have to pull, again build, again do this deploy and all. So what are the problems you have now seen? Every time when a new environment will change, we have to set up this infrastructure is point number one. Point number two, on each and every environment, we need to build the source code and then deploy the source code. This is point number two. So that means the source code, the software, source code here, nothing but software you consider. So software here, what happening? Transporting from one machine to another machine or one environment to another environment. What we are transporting? We are transporting the source code actually. Again, that source code we have to build in each and every environment. Assume here the source code built successfully, but here the source code building failed. Okay, source code building failed here. Don't know what is the reason. So maybe wrong check-in happened, or maybe wrong pulling happened, or maybe wrong merging happened. Reason is whatever it is, but source code building is happening, not happening here. Assume source code build happened, but not deployed properly. Deployment issues we are getting here. So those are all what actually environment issues we definitely can get if we transport the source code over the environments. Again, that source code need to build on each and every environment. So this is the problem without container technology. This is the problem. So let us revisit the problems that I have already have documented in this document. That's the reason I'm not typing. So if you can see the problems, when all the developers written the code will be merged into a dev environment, we need to do the following activities: create dev environment machine, install the required technical stack like JDK, Tomcat, Node.js, MySQL, etc., and pull the source code from the dev release branch, build the source code, and deploy the var file or jar file, whichever we got as part of the source code build outcome, that we need to deploy in the application server like Tomcat. Again, when we go to so when the code is integrated on dev environment and unit or integration testing is done by the developers, then all these merged features, it will be released to the QA environment. Then on QA, what we need to do? Again, we need to create one machine, install the technical stack, then merge the dev release branch with the QA release branch and pull the source code from the QA branch. Again, build the source code, again deploy the source code, and then again deploy the source code into the application servers. So this is a tedious process. If we observe point number one, setting up an environment with the required technical stack installation will take time on each and every environment. And it is a repetitive process when any new environment is added. That is problem number one. So when new environment is happened, again, we need to build from scratch, right? Taking the machine, installing the Java, installing the Tomcat, etc. We are building it from scratch. So that is the problem. That will take some time, obviously, and also error prone. If you do the same activity again and again, as we are the humans, definitely we may do the human mistakes. That is pretty possible. Then second problem is what, as we are pulling the source code, building it again and again on each and every environment, there is a chance of build issues or deployment issues. If the stable code is not pulled, there is a chance of having this. That is the reason maybe code passed well in the QA machine, but code might not passed well on the UAT machine. So application running fine on the QA machine, application might not running on the UAT machine because of maybe database connectivities might wrong, or here the network enablements may be wrong, or the database installed might not be installed with the proper databases, or the source code connectivity to the database is failing. Whatever the reason is whatever it is, but running in one environment, maybe chance of running in another environment, not running in another environment. because of on each and every environment we are building very freshly. Right? Yes, creating an environment is one-time activity. I agree, but building is happening every time, right? When the source code changes are done, then again we need to pull them, again we need to build them, again we need to deploy them. So pulling the source code, building the source code, deploying the source code is a repetitive process. Keep on we are doing. And also the same code we are building on the dev machine, same code we are building on the QA machine, same code we are building on the UAT machine. Same code, but building on 3 different environments. Same code, right? So building on 3 different environments. So this is the problems if there will be no containerization technologies, right? So how containerization technology resolves this problem? So what I will do is, let me save this diagram. So just let me save this diagram into OneDrive, and then let me create another diagram. So where I will name it personal trainings demos DevOps. Here what I will do is problem without Docker. Okay. Now what I will do is I will create one more thing. So new, I will create one more document, meaning one more image, one more diagram. Just observe how it will solve the problem, meaning how the Docker will resolve the problem. So just let me clear it out. Fine. So what I can do is I'll just copy this and then just paste it here. Yes. Yes. Right. I just copied and then pasted here. Now what I will do is, rather on the dev machine, what I will do is I will install the Java. So now carefully observe what I will do on the dev machine. So what the changes we will apply, just carefully observe, please. Carefully observe, please carefully observe what we will do is, right. So on dev machine as it is, what we will do is we will install Java. First, we will pull the source code from the repository. All the source code will pull. Then we will install Java on this machine, right? No database installations not required. First, we will install Java on this machine, install Maven in this machine. That's it. No Node.js, no Tomcat. No Node.js, no Tomcat. What we will do, we will also install Docker here. We'll also install Docker here. So what we will do is, we'll install Docker. We'll install Docker here. Control C. Carefully observe this. Another diagram I have to. So install Docker here. Okay. Now what we will do, now carefully observe this. What we will do, we now install the Docker. So first Java, Maven we will install, and source code we will pull, and we will build this source code. We will get the jar file. So when we will build the source code, we will get the jar file or var file or artifact. You understand it as anything, jar file or var file or anything, or artifact, anything you can see. So some build file you can see, outcome of the source code build. So assume we got the jar file or var file. Okay. Similarly, what we did, so we installed the Node.js and then we build it, or else we pull the source code of the Node.js, that's it. Then what we will do here is, carefully observe this. We will create the Docker images. We will create the Docker images. So assume this is one Docker image. So we'll create one Docker image. This Docker image contains what, as I have shown, the jar file plus Tomcat. The jar file plus Tomcat. So the jar file is Tomcat. So we'll keep this Tomcat now inside the Docker image. Got it? Now the Docker image contains what? The Docker image contains the jar file plus the server to run it, or var file plus server to run it. Next, what we will do? We will create one more image, right? Where this image will do what? So this is one image. So this is one image. Carefully observe, please. Be close to conclusion. So this is one image. And similarly, we will create one more image, right? So which contains the UI code, meaning Node.js and then the React.js code. So React.js code is here. And this is the React.js code, which will be run in the Node.js. So let me take this Node.js and then let me keep it here. Okay, so we will pack the Node.js and then the React code inside the image. And what we will do, similarly, we will take one more image. And in this image, what we will do, we will pack the database. So this is image we will create. And here, this is the image. So here what we will do, we'll keep the database here. This is the database. Right? Now what we will do, these images we built, right? Sorry guys. So these images we built, right? These images, what we will do is, we will publish these images to some central repository. For example, we have such a central repository called Docker Hub. So let me take the Docker Hub. So we will publish the images that we were created to the Docker Hub. So this is the Docker Hub. Now, whatever the images we created, right? So these all images will be published into this Docker Hub. Now, what the image contains? Image contains the source code plus runtime to run the source code, isn't it? That is what we build inside the image. Runtime to run the source code. The image contains the source code, meaning source code build actually, not source code even. Source code build, meaning when the source code will be built, what is the outcome we will get? So that outcome is we kept inside this image, and also to run that source code, what is required, we kept it here. Now other side, other machines will do what? Other machines will do what is, let me take this QA machine and then paste it here. So what this QA machine will do what is, QA machine what is now do is, we no need to install all these things. Rather what we will do is, simply we will install the Docker. Rather simply we will install the Docker here. That's it. And all these images, right? All these images. So all these images will be, all these images, right? All these images will be pulled from this Docker Hub. So all these images will be pulled from the Docker Hub. That's it. See how it resolve the problem. No need of installing the Java, no need of installing any software. Just install the Docker and then pull the Docker images. And here only one-time code building is happening here. So from the dev branch, taking the code, building the code as a jar or var, and then creating the image. That's it. That image only using on the QA machine, and that image only will be used on the UAT machine, or that image only will be used on the any other machines. So code building is happening at only once now, and image is creating with that build code, and that image we can deploy on any environment and any number of times. Right now, what happened? The lot of repetitive task, repetitive process has been eliminated with the help of this Docker. And also here we are not transporting the source code. Rather transporting the source code, we are transporting the image which contains the source code build result, maybe jar or var or dist folder or maybe whatever it is. When we build the source code, whatever the outcome we will get, that outcome place to run that outcome, what is the environment is required, that runtime environment we are providing inside an image, and that image we are transporting. So again, on the other machine like QA machine, no need to build the source code, no need to get the artifactory, or no need to get the outcome of the build. So just need to get the image and then run it. That's it, nothing else. No need of having any extra software installations here. And see this, how easily the application has been transported from here to here, right? So that is the benefit of Docker. So that's how we say Docker is a shipping tool. What it will ship? Software it will ship. How it will ship? As a packages. So Docker is a software packaging tool to ship the software or application from one place to another place, meaning one environment to another environment. Got it? So that is how the Docker will solve the problem of the source code transportation to the various environments and building it again and again. So those problems will be solved by the Docker. Okay, any questions? Any questions? Artifactory meaning build actually. Source code, when we build, right, we will get jar or var something else. The outcome of the source code build is called as artifactory, like zip file you can say. Right, anything else? Any questions for me?
I have one doubt.
Yeah.
Here, whenever deployment completed, they are moved to testing. Testing said some issue is there. That time they are fixed the code. Again, some bugs they are fixed the code. Again, you are creating the image and we need to push that one, or how they will?
Exactly. When the source code change is there, again we need to build the image. That image we need to push here, and that image will be taken here. But see, code building is happening at only one place. Earlier, what happened? When the code changes will be happened, that code changes will be taken here, build here, tested here, and merged into QA release. Now QA release machine, QA machine also taken the source code, build and then deployed. Then UAT. The UAT also build the source code, pull the source code, build it, and then deployed. Build happened on 3 different places for every change. But now here what is happening? Build is happening at only one place. Whatever the same build tested by the developers, that is testing by the QA1. Whatever the QA1 tested, the same will be going to the UAT1. So only one time we are building here. Got it?
Oh.
Yes.
Sir, one more doubt.
Yeah.
Sir, in the dev machine, we have 3 images, right? Like node with React image as Docker image, and database as with some stack as one image, and the other one Docker image. Right? Why all these entire application cannot be in as a single image? Sir?
Correct. Entire application can be also put into a single image. But what we are doing, each and every image will be run as a container. That container meaning one process. So for example, Tomcat will run as one process, Node will run as one process, MySQL run as one process. If the 3 processes will put into a single container, there will be a chance of occurring the process interference, and also that whole container will go slow because of these all 3 processes will listen at a time and then occupies the memory. That is the reason the whole concept of it, keep each and every part of the application or each and every runtime is one image where it will create one container, meaning one process. So this process are two isolated, and this is two isolated, meaning what one container is doing don't know to another container. So they are individually separate, isolated. So process interference or container interference won't be there. The problem of these thread interferences will be resolved, and then performance will be improved because those are three independent threads and multi-processing, parallel processing will be happened. So more performance will get. Got it?
Yes, sir. Super, sir. Thank you, sir. Got
Yeah.
it.
Yeah. Okay. So any more questions? Yeah.
One more doubt is there. For example, you have mentioned MySQL. In MySQL, for example, I have changed one table.
Correct.
One table I have changed. That time we have to take complete image for MySQL.
Okay. So MySQL one table you have done the changes, and basically the data we will expose. If it is the MySQL case I am talking about. Did you remember yesterday we discussed about the volumes concept? So what we will do, we will expose the database data into the volumes. For example, this is one volume storage. So when you do any database changes, that will be recorded in these volumes. So what now we will do, the other MySQL images will refer this volume to get those changes. So no need to build again this MySQL as a new image with the data. That won't be happened usually. The MySQL image updated with some data that will be re-listened by the other images to get the updated data.
Okay. And one more thing, we need to use Docker Hub on there. Any other thing we can?
Anything. A lot of registries were there, but for namesake, I was taken the Docker Hub. There is a Azure provided ACR, Amazon provided ECR, Elastic Container Registry, Azure Container Registry, Google Container Registry, and our own private, like how the Docker Hub. Similarly, we also can create our own private Docker Hub, that is Harbor. So we can use Harbor to create our own Docker Hub. And JFrog is also acting as a one Docker Hub, Nexus repository. Lot are there actually, but by default, Docker will use Docker Hub as the registry to keep the images inside in it. So that is the reason I was taken this Docker Hub as an example.
Okay. Thank you.
Anything else for me? Yeah, if nothing is there, I'm stopping the demo, folks. I think this is the last demo. From Monday onwards, we will be on the new link, and then our classes will be continuing. Now we were completed the first step. What is the problem? There will be no containerization technology, and we understood the solution. And now we got what is Docker, right? Docker is used to ship the software application, not software code. Software application build, software code build will be packaged and then shipped from one environment to another environment. So Docker is using as a shipping tool. So how to install the Docker on Windows machine and AWS EC2 machine, that we will see on the coming Monday. If you are interested, complete your registrations and then come by the Monday. So Monday, I will provide all the notes to you, all the notes, Google Classroom access and all I will provide on the Monday. Thank you so much. Thanks for your time, for being spent with me. Thanks for your opportunity. See you on Monday. Thank you.
Thank you, sir. Very nice. Thank you.
Thank you so much. Thanks. Bye.